My name is Narek Tivasyan. I'm product director of Nebius. Together, I'm hosting this webinar with Lauren and Benoit. If you can say a couple of words about you, it'd be great.
Sure, I'll start. So hi everyone, I'm Laurent. I'm solution architect at NVIDIA, and I've been working for the company NVIDIA for 3 years. How about you, Benoit?
And Benoit here. So I'm part of the enterprise software team for NVIDIA, covering our cloud partners. And I've been in NVIDIA for the last 7 years. Okay, so glad to be here. Back to you, Narek.
Yeah. So today we're gonna have a very interesting deep webinar about Blackwell GPUs and their family and how they're gonna change our world this year. It's gonna be very technical. It's important to tell you in advance. It will be really interesting to understand you, our listeners, better, to understand who you are. So we're gonna create some small poll. Please fill it. So we will just know your roles better, and we're gonna understand how deep should we go through this webinar. When you are filling it, I want to go through the agenda, what we're going to cover today. So today we're going to cover actually like the problem and some solutions, like problem about what we have to improve to make AI better used in the world. We see that a lot of Gen AI is adopting right now, but we need more and more production usage. So I'm going to focus on the problems and like obvious solutions. Then I'm going to pass microphone to Lauren. He's going to tell you details about GB200 architecture and how can you leverage it to make innovations. Then Benoit is going to tell us a real-world example of the application of training and using models in robotics. And then we're going to end with my part, and I'm going to tell you how Nebius can help you to adopt Blackwells, particularly GB200s. And in the end, we're going to have Q&A. To be honest, please feel, if you have questions, please write them any moment that you have these questions. We will try to answer all the questions in Zoom. And in the end, we will answer to some of the remaining questions by ourselves. But we're going to have like pretty packed agenda, so please do not wait to the end. If you have questions, like spit it out in Zoom chat any moment. So I see that we have a lot of technical audience. So I think it's going to be interesting for you. And I'm going to start with problems and some solutions. So what problems should we and we will have this year? I formulate it's on the high level that we're going to scale the resolution of the transform. What does it mean? Actually, like there is a simple example, not obvious one, with LLMs. No, we're going to talk about LLMs and diffusion model in mix, as both of them are transformers. But like there is important obvious thing that if you want to change the context size of the LLM, you need much more memory than actual context size, quadratic times. So it's like a basic problem of like quadratic scaling of the attention mechanism. Much more basic and simple example, it lies in diffusional model. So if you want to change size of the artifact, size of the image that you generate with diffusional models, for example, 8 times, you will need 64 times more compute. So it's like problem is quadratical and it's really looks good in this slide. So there is like a square. If I want to change the size of the square 2 times, like you will see that it's going to require much more, no, not 2 times, but 8 times more memory, and like the same with any scaling resolution. What's new ideas what new capabilities will be available? So of course there are a lot of application of Gen AI. We're still exploring it, and it's good that your listeners are interested to explore it. But there are like some obvious ones that I want to state. So basically, like we will have much better medicine. It's going to work with higher resolution images. We're going to see much precise diagnostics of the problems that is happening. Of course, there is like a lot of things is going on in multimodal, in diffusional models. We're going to have much more generated content. Can't say that it's good. We're going to have much more generated images in our vaults. But finally, I think this year we could, for example, have fully generated production-grade motion pictures or games. That's like a lot of research is put right now. And we see that all the artifacts that it's generated requires are not as big in to be used in production. Of course, there is a problem of deeper, a new area of deeper research that was recently introduced as a service in OpenAI or in Perplexity. And of course, like having larger context will allow us to run this task much better. And of course, with robotics, we're going to have with better compute, and like with better and larger context and resolution, we're going to have much more better, smaller models, and robots going to work with a lot of inputs simultaneously with better quality. So there are a lot of new requirements to the hardware if we want to scale the resolution. Of course, I told memory will be used in larger scale. We're going to have larger data sets, larger generated stuff, and it's going to require much more memory in the cluster system and, of course, in the storage system that's new. Memory bandwidth is all requirements also going to grow because we will operate with larger artifacts, larger models, more parameters. Of course, to run these models in inference, we will need new ideas, and we will need like lower latency inference finally to make a lot of operations more production use. So there are a lot of research also that is going on around optimizing this problem of scaling to make it not quadratical. But today we're going to discuss another solution, is like to have new architecture of hardware that's going to help you to get your tasks and solve your challenges. So here I'm passing microphone to Lauren. He's going to tell you in details about GB200.
Sure. Thank you, Narek. Quick test. I've got some audio problems. I'm sorry about that. I
hear you well.
Yes, I think yeah, but it's coming up to me. It's always, the kind of, I'm on roaming, so I'm very sorry about that. So if by any means, I keep having this, back and forth audio problems, I may have to cut the video. Sorry in advance. So I say hello to everybody. At least you see my face. You know who I am. I'm not an AI agent,
Not yet.
But okay, in case of, you won't be surprised. All right. Hey, everyone, I'm Laurent. I'm solution architect. I've already introduced myself. So happy to be there. Thanks, Nebius, for having this joint, webinar. So my goal today will be to walk you through to the, I would say the logic, the rationale of why we designed the GB200 NVL72. And I hope you will enjoy it. So as an introduction, I'll start by tackling, those difficult questions of the whys, which are fair questions. Maybe one bit of an introduction also about me. I will definitely, talk fast, and I've got a lot of information to provide in a very, short time. So anyway, just put in the chat if you think that it's going too fast. I'll just, slow down the pace and maybe, cut off, some slides. But yeah, let's do it this way. So yeah, leading the charge, facing the whys questions, because I think at NVIDIA we realized that, it took our customers quite some bit of time to actually understand the rationale for all, the improvements that we are incubating or integrating in our design. So if I roll back a couple of years ago, to our first DGX. DGX is our own system, our own reference, platform system, the DGX1. We kind of always face, those tough questions, and the first of those ones were, why the hell would we need, this NVLink, technology? Surely at the time, most of the neural networks, were supposed to be trained on a single GPU, and that would be that way, for ages. But I think that history proved us right that we kind of truly believe that the neural networks would grow eventually, and that people would appreciate the virtue or the value of the NVLink all of the time. But immediately after that, we were challenged by why do we need this abundance of interconnect, network interconnects in the same DGX box? Because again, in 2017 maybe, I think this is where we were kind of facing the challenging series of questions. Well, training a model on a multi-node way was very challenging. I think TensorFlow couldn't come up with some decent implementation before not before its 2.0 version, and we were all struggling as early starters with this Horovod from Uber implementation with MPI, which was very fragile. So yes, I mean, if you get stuck in the in the instant when you don't see what's going to be needed likely ahead of us. So, and from the networking, we went to be challenged to the C2C. So the C2C stands for chip to chips. This has been introduced with the Grasshopper super chip. Maybe it's simply, and I will have a more dedicated slide about this technology. You can see it as a very tight interconnection between the CPU and the GPU. It brings hardware coherency at the hardware level, and you have this very, very very fast and huge bus between the GPU and the CPU. And actually, the GPU can read the memory CPU the same way the CPU can read its own write. That's a very, very nice advanced. So, and yeah, we've been trying to address these questions over and over, and it can be generalized to why at the time we entered this mixed precision training. Why did we conceive or design the tensor core? Why did we put the transformer engine library into the market? And why would we need this micro tensor scaling technology? That will have a dedicated slide also. Well, okay, we can keep on going on over and over about those questions. I think in order to understand again the positioning of this particular platform, the GB200 NVL72, it's important to to acknowledge the fact that when I say we, NVIDIA in its general form, not necessarily build systems that AI researcher would need in this instant moment, okay, in the instant day, okay, today. But instead we kind of build systems, and more importantly software as a platform that defines, or will somehow very humbly defines how AI may look ahead, okay. So that's and with the fast pace of AI evolution, what is ahead is probably behind by the time we just say it. But that's the philosophy of the design, the original design of the GB200 NVL72. Okay, so if we take a moment and look at where we are today and what's likely ahead of us, again, maybe ahead of us is probably behind us, but now we have two kind of evidences on this slide. So on the left, we have the evidences that we have a probable future model scaling, meaning all the models will inevitably and eventually grow, and we'll see how and why. And on the right, that's from a paper from Meta, we see that we are not even close of running out of data for training, and that's maybe sometimes some misperception, but this is definitely what we think where we are standing at the moment. Again, the reason why the model keep growing over the time is actually known for many years. They follow what I would call the scaling laws. It's an empirically demonstrating scaling law. So if I take the laser pointer, let me try this. Yeah, no. Okay, well, anyway, it's that's this area, this region here. Sorry about this very bad drawing. And it's kind of empirically, as I said, demonstrated law that says that whenever you increase the amount of data, okay, used to train those neural nets, as long as those networks, grow proportionally, with the training data size, they will improve, but they will not improve like, random. They will improve in a very clockwork way, very predictable way, with this power law region. And we can observe this, phenomena, this sighting in any AI area, any AI domain that you could pick up. It's always the same law which applies. And on top of that, I mean, they just don't get, a better or it's not a free lunch. I mean, they will probably get even, better at tasks that they were not originally trained, for. They will probably get, better at what we call, few or even better zero-shot learners, and that's really, appreciated. And on the right, if I still have, on the right, okay. Right. If we look at this, well, I'm very bad at drawing, I'm sorry about that. But if we look at this area, okay, for the biggest neural networks, so that's again a paper from Meta. So I think we're looking at some, llama instantiation. So the biggest models which requires, the highest level of compute, you'll see that you don't need, these extra tokens. You don't need this extra, training corpus. You're actually achieving a very decent validation loss, with less data than you would have at NT. So you have plenty, you have exactly the right amount of data and you're not running out of it, okay? And well, on top of that, I would argue that, the majority of those, models were trained in English. And if you do the ratio of the number of, English native speakers on planet Earth, I think we can be very much, not worried about running out of data. We have plenty of text at our disposal, all right? And again, it's just, so I need to step out of this mode to get back. And this is just the first wave. What I thought originally would be, ahead of us is already there. And I mean, we've seen the explosion of multimodal, Gen AI, multimodality models. We've been doing very, I hope this thing is not going to stay. So, and we've been doing very interesting stuff, either in biology or chemistry. I mean, like I said, making even traditional, networks topology that we used to use in natural language processing, but making them much bigger and training them on dramatically larger data sets, we were able to achieve fantastic things like, training them in a surprised way with nucleotide, for instance, on biology or chemical compound. We actually were able to beat or to get very close to a very wide range of state-of-the-art benchmarks. So I think everywhere we look, we see this, kind of scaling law. I think we are likely, and when I say we, it's a kind of, consensus at NVIDIA, that we are likely to see even larger neural network trained on dramatically, larger data sets. And more importantly, and that's goes back to the original intent of this platform, the GB200 NVL72. I think those neural networks will likely look slightly different, okay, from what they are today, because they will adapt inevitably to all the change and the hardware acceleration that we are incubating in our platforms. All right. So, and as an illustration, and it's a current illustration, okay, I think a mixture of experts have made some buzz, recently on the news, but yeah, we could take, this comeback of mixture of experts, for instance, as an illustration. When I say, well, comeback, but anyway, I'll explain a bit later, but, mixture of experts, it's kind of very, strange architecture. You have these different, almost discrete components. They are called experts. They're partially isolated from each other, but they really require this additional, communication patterns, all in all, combine and dispatch. And that makes, the GB200 NVL72 particularly good at supporting this kind of neural nets, okay? Again, I use the expression comeback because I think those models were first described a long time ago. I remember a paper from 1991. So yeah, it goes a while back, and I think around the same kind of time frame to 2017, 2018, we were all convinced that those mixture of experts will become the de facto standard. How we will develop evolve the neural net models, but and actually they did not. So they might become the next Graal. We don't know. They might be not, but again, things will evolve based on what kind of the kind of hardware we are just pushing on the market, and we will, I think, also likely see the emergence of what I would call wider much wider model, which actually are targeting, they're getting better at targeting, full generalization. Okay, and if you look at all the profiling metrics, it's not really. I mean, it's a very, I would say, a heavy simplification that I'm making here, but again, it's not the size of the model, the number of parameters, or even its depth, which really put the highest pressure on the systems. It's really its width. And with that evolution in width of the models, you will definitely need, a bigger unveiling domain like the NVL72 to take advantage of it. Okay. As a note, I would probably add that the GB200 might become also, or is already by design, by nature, a very good inferencing system. Narek started, the talk by, illustrating the increase in context length, in sequence length, in video definition with quadratic, factors. So I think we will come up, and if it's already not the case, I guess, with very, very advanced, memory distributed system that will, be, execute perfectly on such system. And again, I remember I mentioned this very tight interconnection coupling between the CPU and GPU, and we'll see that both training and inference will take advantage of this hardware acceleration. Right. So benchmarks. Generally not comfortable that pushing benchmarks. So you really need to be fully transparent. So I will go with the disclaimer, and if we have specific questions, we can discuss along. So those are projected performance. Those are public benchmarks. So I'm not taking any risk. They are perfectly available on our website. They are subject to change because it's projected performance, but they're here to illustrate what I would call some kind of heavy processing of up to speed, or actual technology, like mixture of experts with some kind of heavy dimension. We're talking about a 1.8 trillion parameters model, and you can see by its own design what we have anticipated, forecasted is very impressive speedups, both on training or in inference. 4x and a 30x in inference. I think it's the first time talking latency that we're talking here. I need to double check, but those are impressive speedups. And what is more, those projected performance were done on a very massive infrastructure. I think it's more than 32,000 GPUs. Okay, so that means that the GB200 NVL72 was really designed for the next generation of AI development. Maybe I should pause a little bit, slow down a little bit, just let me know, to explain actually what is a GB200 NVL72. We've been, discussing about this, platform, but in its essence, it's a full rack appliance. It comes as a rack, okay, and it has obviously 72. This is why we call it NVL72. 72 GPUs, all interconnected through this very advanced, latest generation unveiling fabric. So when you look at the metrics, the feeds and speed, it's quite impressive. In this configuration, each GPU amongst the 72, you pick two out of them, each GPU can talk with its any peer, okay, at 1.8 terabyte, not bit, terabyte per second, okay, in a peer-to-peer communication. This is huge. So this kind of fabric, with the primitives and the, memory primitive that it allows, can actually transform the whole rack as a single massive GPU when it comes, to perform AI workloads. And on top of that, in each node, in each rack, each Blackwell GPU, because it's Blackwell, okay, GPU based, can really talk to not like its own CPU, but can read into the CPU memory with almost the same speed as the CPU can read its own RAM. Okay, so that will, and we'll see a bit later, but will allow you to develop and to enable some very advanced offloading strategies, which dramatically increase performance both on training and inference. Feel free to, to shoot questions if, there's something not clear about the, maybe Narek can also, Nebius can answer, but it's a fantastic beast. I mean, it's a huge, huge, huge platform. As an illustration, and Benoit, let me know if I'm, on track, on time. I can squeeze if it's needed, but no problem.
You are good. No problem.
Okay, so I will just go through. Yes, as I said, you can actually, use this very tight connection between the CPU and the GPU in a very effective manner, as triggering some asynchronous, activation offloading. For instance, you will offload activations of your model to the CPU memory, okay, during the forward pass, and then recall those activations when needed during the backward pass. So as it's done asynchronously, you can actually efficiently, hide copy latency, both on offload and recall of activations, because you have this tremendous bandwidth between the CPU and the GPU, and you would pay, virtually barely no cost doing that, okay? You can also figure out beyond, the activations, you can also offload partially or even totally, parameters, okay, even a full layer. If you are doing some kind of LoRa fine-tuning, that would be, a strategy you would adopt. So that is definitely a very nice, feature which can enable tremendous, speed ups and performance improvements in fine-tuning strategies. And that's probably, where I would, well, no, I don't have the pointer anymore, but I would stress, this disclaimer here. The implementation of coming support is there. It's really, the essence. GB200 NVL72 comes with a lot of, hardware support. The implementation is just incubating, being upstreamed, in various places. So as far as fine-tuning, I think we're still pretty much overall in the proof of concept stage. I think we have, this asynchronous offloading, feature enabled in our transformer engine library. I think there is also some kind of project of proof of concept with Meta, with some LoRa, fine-tuning for Llama. I will leave it, to your own curiosity. It's not there fully yet, fully implemented or upstream, but it will be there eventually. Okay, so again, support is there. The community, the open source community needs to implement it. That's how we see things. Now, if we move on the inference side, I think there is also a nice adaptation of this, acceleration strategy. The idea is to keep, persistent KV cache, the one which is, persists between user queries on the CPU memory, while the actual, the regular KV cache stays and remain on the GPU. So that also provides a very, very, very decent speed up in first time to token, latency. That's a really, really, appreciated strategy. And you can also generalize this, this approach by offloading partially, your model through the CPU memory, because you will be able to recall in an asynchronous way, hiding all the copy, overhead in a very efficient manner, and that will allow you, to process, much, much, much bigger model than you would have imagined, given, the memory capacity, which is already good. I mean, a Blackwell GPU in this particular configuration comes up with 186 of HBM3E, density. So that's quite, already impressive compared to what we have at the moment with the Hopper generation. And I think, yes, that's maybe one of my last slides. As the inference is concerned, I think we are beyond the proof of concept now. Everything has been upstreamed and it's fully functional. And that is in our TensorRT LLM framework, which is our, AI framework, inference framework. And both approaches are now being enabled, both, the persistent KV cache acceleration and the weight or parameter, offloading strategies. They are both activable and enabled in our TensorRT LLM. So I'll leave it to your curiosity if you want to try it. And as a very, very last slide, and I will hand it over to Benoit after that. Again, we have now evidence that the training with FP8, floating point format, produces excellent results. It works. So that could have been the challenging questions, a few years ago when we introduced, this FP format. And now we're looking at going a little bit beyond, further with this very intelligent, 4-bit precision. The MX FP4 for the weights and the MX FP6 with all, the declination for the activations and the gradients. And, following what's, the research and the academic is producing at the moment, we have good intuition, good insights that it will be also successful. So again, it's the same disclaimer. The support is there. The implementation is upcoming. GB200 NVL72 is a Ferrari. You guys are the pilots. Just go ahead and drive it. That's probably, the way you can think it in a very, I would say, simplified and humoristic way. So with that, I think I'll wrap up my presentation. I hope it made sense. And I'll hand it over to Benoit for his illustrated example on the world foundational model. Thank you. Thank you, everybody.
Thank you, Laurent. Just a quick feedback. So Richard and Nageshwara, please post your question on the Q&A so Laurent can have a look now. He can open the Q&A panel. So thank you for this.
Thank you.
On my side, I just want to add some more color to the why of the NVL72 architecture that Laurent just covered. One of the reasons for the NVL72 architecture is actually to serve the needs of a new era of AI models. And one example is physical AI, and by extension, world foundation models, which are basically aiming for autonomous vehicles, self-driving cars, and general robotics as a whole. A bit more context here. So one of the reasons for physical AI to emerge is really to address the fact that dealing with physical world data is extremely costly to capture, to curate, to label. And to resolve this challenge, researchers have built so what is being called world models, whose purpose is to literally learn like humans from real world data. So the idea is to predict what will happen next based on very various type of inputs. And world models actually are based on multimodal generative AI. So inputs can be videos, text, sounds for now, and from which we are basically we derive actions to be performed by the robot in the physical world in the form of action tokens. So that's really interesting in add-on or in replacement of traditional physical world data, but nonetheless, building this type of world foundation models come with its own challenges and requirements. So the first obvious challenge is the amount of photoreal visual data it requires. So we are talking about petabytes of high quality visual data. We are talking about millions of hours of video footage. And then there is the fact that while acquiring the data is already very difficult, it's also even harder to filter, to curate, and to tokenize this amount of hundreds of petabytes of data for the training by itself. So ultimately, this requires some very performant and particularly resource intensive trainings. And I mean, we have to be conscious that training such models costs literally multiple millions of dollars in compute time, and it requires access to a very large infrastructure as a whole. Last but not least, it also requires, I mean, for fine-tuning and to develop the model by itself, it requires some very skilled engineering and research teams, obviously, because this is a new class of AI, but also to develop all the frameworks and the tools to achieve this very specific class. So why I choose to address this topic as an example for NVL72, it's actually because it turned out that we have some experience in this field because we created our own models that we incorporated into a complete development platform for world models, and we called it Cosmos. And in this slide, I want to illustrate two things. First, when I mentioned the fact that it requires a very strong infrastructure and I mean considerable amount of computation power. I mean to achieve and to train the foundation models, the world foundation models. I'm going to detail just after. We have spent quite a few amount of hours of training on our own infrastructure first, and this not also it requires I mean kind of a big infrastructure to achieve this model, but also we had to be very careful and in developing a precise data strategy, mixing various type of data types, and in the way we optimize the overall pipeline, especially around the curation, to basically make the models as accurate as we wish. So to enter the details of what is NVIDIA Cosmos, I mean, I will put it this way. So it's a kind of state-of-the-art world foundation model development platform. So it comes with several parts, and basically you can just go on the GitHub and have a look at the details if you're interested in that. But to make it very simple, so there are two families of foundation models. One is diffusion, the other is autoregressive. So you can basically one is a kind of you can think about it like a style transfer. You feed the model with static or dynamic rendering, and it makes it look extremely realistic. And if you don't have any renders, well, you can prompt it. And basically you will be quite amazed by the quality of the results it provides. You can try it now on build.nvidia.com if you're interested in it. And there is the autoregressive model, which is basically taking still images or videos or still videos, and the idea of this model is just to generate the sequence of the next frames. So and this is these models are available in various sizes and types. These are the models that requires these thousands hours of training each. There is then a tokenizer. I mean, a very extremely efficient tokenizer. So basically, taking the video in, compress it into the latent space, and it does it very well. I mean, we observe here a mix of this tokenizer with the latest hardware. I mean, we achieved like an order of magnitude faster reconstruction times than any class open tokenizer. And finally, and this is where I want to end my presentation. There is a video creation and processing pipeline. So to help you guys take our models and fine tune it and basically develop your own foundation model. So this video creation part is extremely challenging, and to do that we have developed our own full creation and processing pipeline from our Nemo platform, and this covers decoding, splitting, transcoding, I mean filtering, annotating, and so on. You name it, part of the process, and it's obviously extremely optimized for our latest GPUs and architecture. And what we are achieving here, basically allowing developers to process and annotate millions of hours of videos in days instead of years, literally. And this is an extreme game changer, mostly for the autonomous vehicle and robotics companies, which is the core aim of the Cosmos platform, because these guys have hundreds of millions or even billions of hours of recorded data, and that need to be curated into training data. So this is extremely important for them. To touch base on, and I want here to go back to pure performance and why the NVL72. It's basically from the chart one, from the one on the left, with a Nemo curator, which is basically state of the art, optimized for a Blackwell architecture. I mean, we are basically putting aside the CPU pipeline, but we have a net by 3x acceleration compared to Hopper. And when we are talking about millions of hours of videos, again, having a 3x here is extremely interesting for the processing time. On the chart 2, I'm touching the VRM captioning stage, which is about 70-80% of the filtering pipeline. And here, with this creator activated, we are gaining another order of magnitude with or without the curator with the same platform behind. And this optimization is made of exactly what Laurent covered. It's made about it's FP8 optimization. It's made of specifically tuned libraries. There are two major video codec libraries leveraging our latest hardware. It's made of course about from QV CV CUDA optimization, and all of this put together allows the platform to basically to perform 10 times better than it used to be with literally the same hardware. So that being said, I'm giving it back to Narek.
Yes, let me wrap up basically and tell you about our plans, like how Nebius could be useful with adapting Blackwell's GB200. So I will we have like a lot of talk about benefits of GB200. I would say that also there are some challenges actually to adopt it. I'll go from the middle. First is that it was discussed and told that like using GB200 is like one of the most efficient ways to train and run models. But from the other side, power requirements and power density requirements of this rack is huge. So air cooling is not enough. So you can't just buy this box and put it to your any data center. You have to find special data center with liquid cooling and do this. You have to have like expertise, timing, and resources to find liquid cooled data center. Second thing on the left, it was with DGXs, even with B200s with one server, like you will have you could have one server experience, one operating system experience. With GB200 rack is actually 18 servers. Every server contains 2 superchips. So basically, to work with this system, you will work with a cluster like from the start. And third challenge is actually about performance. And like you see that this rack is highly performant. And usually with more and more performance, you will need more and more faster shared storage to work with the cluster of the systems. So basically how we can help you to adopt these challenges. First thing is that like we're a company whose expertise is to create, build, find data centers for the special compute. So like you do not need to hire a group of people for that and do it. We're doing it right now for you. Second thing is that we're With Nebius, we're AI cloud. We are not a place where you just come and rent GPUs. We're a cloud platform. We have managed services, and of our main focus on the managed services is to provide you managed schedulers. So basically, right now you can use managed Kubernetes in our platform. We are developing managed Slurm based on our open source operator, Slurm operator on top of Kubernetes, which has a lot of integration with our platform around monitoring, auto-healing, auto-scaling. So in our platform, you can consume GB200 using this. You do not need to reinvent the wheel, install everything by themselves, support by themselves. We are here for you. But if you want to install it, of course, it also will be possible. We have such customers with deep expertise. Third thing is about storage. So we believe that and know that requirements for the storage will grow with higher dimension, with higher resolution of the images, particularly multimodal. You will get higher throughput requirements than you had before, and data sets or artifacts that you generate will be larger. Where are we now? Actually, right now we are developing GB200 servers to be available in a platform. I can't disclose particular dates of the availability, but I can hint you one of the servers that we have right now in our factory, and we use it to assemble it, test it. We're running like first tests on it, and sure, one of the next stages is to finally add it to the platform. You can already come to us, get first access, because we pre-book some access, because when they're going to be available, we believe it's going to be much more demand for it. Usually, like with every new model of the GPUs that NVIDIA offers, we see like very high demand of it from the start. So you should think about it ahead. It's also important to note that we will also support B200, not only GB200s, but B200s, which is very similar with H100 to H200. I mean, architecture-wise, it's not a big change. But like both of the architectures, both like B200 and GB200 will be available. So if you want to start testing it, using it, or have early access, please come to us, pre-order. We will help you organize some test environment even before we release it, and you can start touching it. So here, in this moment, I'm stopping. Thank you for your time. We have some questions that we kept unanswered. So I'm going to go through this, and we'll ask help of Lauren and Benoit with it. I'll start with the first question that it was written in the start of Alex Laptev. So basically, I will summarize it from my perspective, give you answer, and maybe Lauren and Benoit also can have some insight. So the main question is that Alex and his team developing a startup that uses and service that uses RTX GPUs, and like they want to understand the criteria to move from RTX to other enterprise grade, how it was called in his question. So what are the criteria to move to other GPUs? I will start, and maybe you can give your insights also. First thing is that basically a question about availability of GPUs in cloud platforms. I would say I'm not sure that RTX GPUs are available in like cloud. They could be available in some hostings, like smaller companies, not available in the cloud. What is like why it's not good, for example, like in clouds, you can have GPUs with platform capabilities, like ability to create GPUs on demand and pay for what you use. You do not need to rent them on the longer period. So in our platform, you can come, for example, take L40Ss and use them in auto-scaling mode and pay for usage. Another like more technical thing, why you need to change a GPU type usually, like for the inference. From my perspective, the most important factor is whether you can fit your model into the GPU memory. If usually GPU memory is enough, this is something that could be a reason not to move. But if your model is larger than GPU memory, sometimes, not sometimes, but I think in the most cases, it's much more efficient to put it into the GPU that will fit it to the memory, mostly because like GPU memory speed is like much faster than any interconnect between GPUs. And like we see a lot of improvements, for example, for customers who used who inferred larger models with H100s when they moved to H200s, and like one of the main advantages of H200s was higher memory per GPU. We see that like they got much more faster inference. Third thing, yes, again is about, I think, yes, third thing I think is about cloud again. So like your service could require, if you're running some production service, like having GPUs is not enough. Again, you will need like Kubernetes, some object storage, for example, to store your images, like a lot of things to build like full-blown application. Usually clouds give you this. And like with, again, I believe like RTXs are not available in like larger amount of clouds. I think like from my perspective, this is like the reason to move to better GPUs. Maybe Laurent, Benoit, you also have opinion here, please.
I think
I think
yeah. Go ahead.
you covered it well. Maybe Laurent, while you're here, there are a few live questions you can take. So like how many partitions can you create on a single B200 GPU using MIG?
So that is a strange question because if you look at the nature of the DNA, and then I'll circle back with the Alex Labtev's question, but the DNA of the GB200 NVL72, as you saw on the slide, is a full appliance. It's a full rack, and what you want to keep is the NVLink between the GPUs. Otherwise, why so as soon as you, and if it is enabled, that's still to be confirmed, but imagine it's the case. As soon as you will enable MIG, you will shut down the NVLink. By definition, a MIG partition doesn't communicate with anything around. This is a pure isolation. It's an SRIOV, a physical function that we trigger. So you don't really want to use MIG within an NVL72 domain. I mean, this is totally counterintuitive. Okay. Having said that, you can maybe create sub-partition, like splitting the rack in two or splitting the rack in four. Again, it's a suboptimal usage of the rack, but that would make probably sometimes some sense because you have underutilization, or you want to optimize the overall usage of the rack. But by definition, MIG is totally orthogonal with the DNA or the intent of the GB200 NVL72. Maybe it wasn't MIG partition, it was maybe more partition as a generic concept. That is possible. We can split. Yeah, it's a fabric is a network. Okay, so you can create routes, you can create VLANs, you can create separate LANs or NVLink fabrics within the rack. That would be suboptimal. You would lose in terms of bandwidth, but that is still possible.
Yeah, I'll go through another questions. There is a question from Konstantin whether Nebius has a conf UI and graphical models. So like today, you can come to Nebius AI Studio and use text-to-image models in Inference and hosted Inference mode. This is what's available right now. We are actually will launch soon a service which is called application platform. It will be like set of serverless Jupyter notebooks or comfy UIs and like VLLM tools around it. So stay tuned about our news. Soon you're gonna have hosted comfy UI in our platform.
I will type. I mean, I heard, you know, a MIG for GB200 NVL72. Sorry in advance. I didn't catch it. Was for a single B200, which is totally different. Okay, so I will just type in the but yeah.
Yes, I saw this also.
Yeah. I thought it was the GB200. Sorry.
Yes, there is also interesting question. What's your view on accelerated training on conversational AI, which I believe should be a part of world foundational models?
Yeah, okay. I can take it. So far we are treating the conversational AI part, I mean, on our side, from NVIDIA perspective, through its own platform. So basically, Riva is our conversational AI pipeline building platform, and it's already used in robotics to basically being able to be able to communicate with robots. For the training part, it all comes back to the NEMO framework, which I mentioned for the curation piece. Well, basically, it's a model. So the platform by itself, we have a platform for training optimization and building models, which is NEMO. So what we're doing is whatever the type of model we want to build, it always come back to NEMO somehow, and then we create specific models and pipelines and tools that are gravitating around it. For physical AI, it's Cosmos. For conversational AI, it's Riva, and so on and so forth. So, but we're not incorporating conversational AI in the World Foundation model. So far, we are treating this separately, and I think it's a right way to do it.
Thank you. There is another question for Nebius, that we are right now building our own platform. Do we have plans to run our platform on customer side? I would say private collocation. So basically, yes, right now our focus is to build self-service platform that like fully controlled by us. I would say that we are in constant conversation with like sovereign AI cases, like cases where we can bring our platform to the large clusters. So it's like case of like thousands GPUs. If you have such case, let's talk. Also, one thing that wasn't mentioned here in this talk, we run a separate product. It's called Tracked AI. I will write it to a question. To answer the question, it's also like our product that we by default run in our premises. It's like data preparation and training platform that you can actually install, and we can install it in your collocation site. So it may be a case for you. And there is, I see questions coming and coming. Okay, I will choose the last question, I think, like in the order of they've been answered. So there is a question for Gain, Lorraine, and Benoit. We're seeing modern LLMs being built using 2E27 plus flops and models that are few trillion parameters. How big are physical AI models today in the scale of comparison to like in modern multimodal LLMs?
Okay, that's a good question. On our side, I think so. The Cosmos Nemotron model are available in three sizes. I think there is a 7, a 42, and I don't want to make. I think it's 100 and 140, if I'm correct, billion parameters. And yeah, don't quote me. Don't remember well, but I think it's in this order. And about your will it scale? in similar empirical ways and multimodal? That's a very good question. I assume yes, but honestly, this is the very beginning for this journey. It's a new class of AI, so I honestly don't know. I don't know if you have an opinion on this, Laurent, but
No, it's basically, the pitch of my presentation of the, first slides is, I mean, this is an empirical law that we have observed in any area of any, AI workload. So I think it's there to stay. There is probably an underlying, structure, some kind of hidden, pattern that we still can't, grasp. But yeah, I mean, as long as you keep up, proportionally increasing the size of your model with, the data set size, you will observe the same scaling law. So I think the answer is yes, until we change the nature of the models. I don't know what's incubating. I'm not chasing the academic or the research every day because it moves too fast now for me. But yeah, so far this is what we've been observing, and it's very, very impressive how non-randomly and how predictable those models actually behave. That's really, really very impressive. Yeah.
Yes, thank you. And we have to end. I'm sorry that we didn't answer all the questions. We are a little bit out of time, so I want to say that we will answer all the questions in the follow-up that was left. We'll share a presentation with you, so feel free also to contact me, for example, LinkedIn, if you have some questions. And thank you for your time. I hope it was interesting. I hope it gives you additional knowledge, and you can use it in your life to make our world better and more Gen AI. So have a good evening, and bye-bye. See you.
thank you, Narek.